So I have this study guide that I created a while ago. I think it was like last semester or something. And the whole idea behind it was just to give kind of a guide as to what's on the test. It also has 2 sample questions, so you can see the format, just to get an idea of like what the questions are like. And we'll look at a few more. And so I guess just before we get going, there are two finals that you'll take. One is the vocabulary exam, and one is the query/statement exam. I would recommend taking the vocabulary exam first. And the only reason being is I feel like that test is almost in preparation to the second one. It just seems logical. Feel free to do what you want, but that's usually what most do. The vocabulary exam is like a fill in the blank, and spelling does matter. So when you do it, spelling does matter. So it'll look something like this. It'll ask you a question like, what subquery is known as an expression and returns only one column and one row? And then type the single word that would precede subquery to label it in lowercase. So, that's a good example. We'll look at some more here in a minute. The other one is the query/statement exam. And what you do in this one is you actually look at a query or a piece of a query or some sort of real life application. And then you have to answer some questions about it. And some of these have changed quite a bit, but here's an example of one you might see. So the first question is, does it work? Yes or no? And returns what or fails because. So like in this case, we do select C dot first name, pipe, space, pipe, C last name from contact. So works, I would probably put 1, and it returns the first name, a white space, and last name from the contact table as a single string would be the other one. So you can kind of see those ones example. So there's some examples, and then down here, terms and studies. Basically, this is kind of just like a guide to go over the different acronyms, and this is really, I think, a good refresher for both exams of vocabulary and the query. And we're going to go over all these here in just a minute. But I just I didn't spell it out for you because I think that kind of defeats the purpose. I think there is value in going because this way you can go through and say, okay, do I know what SQL is? Do I know what DDL is? DML, DCL, TCL? Do I understand select statements, update statements, insert statements, all that? You go through, and if you know something really well, you can just skip over it. Otherwise, I would highly recommend going doing some reading and use this for notes. So like if this were me, I would probably have this annotating it as a PDF, and be doing some stuff over the top of it, write some notes, add notes, whatever. But this is I think this is a fairly exhaustive list. So anyways, let's real quick, I want to take a look at some some sample questions from the practice exams. So this is a practice query exam. So this is just kind of going to give you some ideas. So you are inserting several dozen rows of data into the bank account table. Which of the following statements will enable you to execute the same statement again and again, entering different values for variables at statement runtime? Right, so this is kind of understanding. Basically, the key here is you want to know, how do I declare a variable? Let's play a game real quick. So which one do you guys think it is? So again, we're different variables for variables at statement runtime. Basically, to make it easy, you can just punch in 2 numbers instead of have to edit the actual query itself. Okay, so we got 1 vote for C. Any others against or for? Oh, we got 1 for B, so we're split. Okay, so there's 2 for this one. Looks like that. Okay, we've got 3 for C, so we'll leave it here at C. You have just removed 1,700 rows from a table that were no longer needed, so we just deleted them. In order to save the changes you've made to the database, which of the following statements are used? Any guesses here? Okay, there's 1 for commit, B, 2, 3. Okay, overwhelming. That's good. You execute the query, select 5 plus 4 from dual. You have never inserted data into the dual table before. Which of the following statements best describes the dual table? A dictionary view containing 2 schema names. Table with 1 column, 1 row using various operations. Dictionary view containing 2 index names. A table with 2 columns and no rows using various operations. So everyone's saying B. Let's give that a shot. You issue the following statement. And we'll talk about it here in just a minute because someone said I don't think I understand the dual table. So we'll talk about it here in a minute. You issue the following statement. Select decode. So here's this awesome decode function. I actually really love this function. Select decode, account number, and then all this. I'm not going to read it all out from bank account. If the value for bank account is 503952, what information will display? 503. Okay, we got 1 for active. Okay, lots of A's. Decode, I don't think we ever actually had decode in a lab. I think we did talk about it at one point with the case statements. We'll talk about that one too. So active. You execute the following SQL statement. Select add months. The 28th of April, 97, comma 120 from dual. What will Oracle return? So if we're adding 120 months, we've got to do quick math in our head. There's 12 months in a year, so there's 10 years. Okay, so someone says 28th of April, 07. We got a lot of those. Okay. You are formulating you're formulating a SQL statement to retrieve data from Oracle. Which of the following SQL statements are invalid? Okay, so these ones are the ones that you kind of have to be quick about to try to locate errors fast. So, which of the following SQL statements are invalid? So we got one that says no from. Any others? Okay, that would be my guess as well. Nope. So which of the following SQL statements are invalid? There's only one invalid one, and it's this one. It's actually good. So most of the certification exams, almost every question is multiple choice for this kind of stuff, which is really hard because, like in this case, we know it's a one choice deal. So the minute we see that there's no from clause here, we know this is broken. We can click it and move on. But if it was multiple choice, you'd have to evaluate every statement and be real careful. You issue a select statement on the bank account table containing the order by clause. Which of the following uses of the order by clause would produce an error? This one should be pretty quick. C. Perfect. And again, once I submit this, we'll actually we'll talk about each one of these because that'll just be good. You are creating some tables in your database as part of the logical data model. Which of the following constraints have an index associated with them that is generated automatically by Oracle? A. Overwhelming A. Okay. You are processing some data changes in your SQL Plus session as part of one transaction. Which of the following choices does not typically indicate the end of a transaction? Overwhelming A again. You wish to join the data from two tables, A and B, into one result set and display that set in your session. Tables A and B have a common column called C in both tables. Which of the following choices correctly displays the where clause you would use if you wanted to see the data in table A where the value in column C is equal to 5 even when there was no corresponding value in table B? So this is a where clause, Joy, not an on clause, which is unfortunate because I prefer the on clause. But so essentially what it's asking here is we're joining A and B. C is the common denominator. So we got one for D, so I'm going to mark it. We got one for B. Which of the following choices correctly displays the where clause you would use if you wanted to see the data in table A where the value in column C is equal to 5 even when there was no corresponding value in table B? So we've got one for D and two for B. I didn't know the first time either. What does plus sign mean? We'll talk about that in just a second. So let's go with B. We'll leave that all there. And let's hit submit and see how we did. Oh, we got 10 out of 10. So you guys did really good. Okay. So real quick, let me just answer this thing real quick. There we go. Okay, so this is actually a practice exam that you'll take. So you can see that this is the kind of stuff you'll actually see when you do it. So you can see how this is a nice nice little thing. So the ampersand marks a variable. That's just Oracle's way of marking a variable. It's kind of like when it parses it, it actually goes through and marks them. And what's interesting is they actually try to throw you off here. You see how it, a lot of people might get confused by this, thinking that that's like, oh, you're inserting an actual like string, not a variable, to throw people off. Anyways, this ampersand is like a very hard-coded thing. Like the only way to get around it is to actually put a backslash prior to the character to escape it. Basically, you have to escape it. So, and the reason that we put this around it is because we want the variable inside to be wrapped in those. So, anyways, they try to throw you off a little bit, but the ampersand is how we mark a variable. And it kind of talks about that. Proceeded with an ampersand character. You have just removed 1,700 rows from a table. How do we save the changes? And you guys overwhelmingly knew this one, a commit. So just as a review, the traditional order is you do save point to kind of save the place. And then you use the commit and roll back to do those things. Commit obviously commits it, and a rollback rolls it back to a save point. You execute the query, select +5 plus 4 from dual. You have never inserted data into the dual table before, which the following statements best describes the dual table. So the dual table is an in-memory table in Oracle. And really, it's really nice because it's kind of like a fake table that you can use all the time. So like in this case, select 5 plus 4 from dual is essentially like saying, like, look, just tell me what 5 plus 4 is. But the way that Oracle is designed, it kind of has to be in there. So there's this table in memory called dual. And that table in dual has one column and one row because it's made to spit out basically one piece of data at a time. Yep, that's a good analogy. So if tables were the hard drive, dual is RAM. And the important thing to know is that it's a table with one column and one row, and it's used to kind of just use it as kind of like a little utility table, like it's just kind of there for stuff like this. Like, and we used dual table before, if you remember right in lab 7 when we do the active flag in that one crazy query. We use dual because we join to it to select a Y and a no, right? So a lot of times you just need, like if you want to cross join a bunch of different numbers with 9, you could do that pretty easily with dual. So it is actually quite handy. And decode. Decode is a function that is used as a case statement. And essentially how this looks, because this one isn't formatted very good, because typically how this is formatted, this should have a better example. Yeah, so typically how this is formatted is like this. So it's a little bit easier to read. Essentially what you have is decode, and then in parentheses, the first parameter is the variable that you are evaluating. So in this case, warehouse ID. If warehouse ID is 1, then it returns South Lake. If warehouse ID is 2, it returns San Francisco. If warehouse ID is 3, it returns New Jersey. If it's 4, it returns Seattle. If warehouse ID is not in any of those, you can add this else. So the last variable is essentially the else clause. And so if it's not 1, 2, 3, or 4, so like let's say warehouse ID was 7, it would return non-domestic. That makes sense, everybody? There, once you see the 1, it's super easy to remember. They're basically just like a little what is that called? Compressed case statement. Okay, question 5. This was the add months. So basically, we add months, and this is more of a math question than anything, right? How many months are in a year? Well, there's 12 months in a year, so that's 10 years. So you take the date and you add 10 years to it. Now you want to be careful with this one because, like, if they decide to throw in an add days one or add years, things get weird. The days one, especially, I don't foresee them. If they do days, they're going to do a smaller. So add months it'll probably look very similar to this. Like I said, that's more of a math question than anything. You are formulating a SQL statement to retrieve data from Oracle. Which one of the following SQL statements are invalid? And we don't have a from clause. Now, this is an example of a type of question that there will probably be a few of. So just as a forewarning, it's not always going to be there's a missing from clause. Basically, you just have to be aware of statements enough to know, like, okay, this is what's missing, that sort of stuff. So and the nice thing is we've all had a lot of practice with the labs. I don't think there is one person who just went flawlessly through the labs, so you should all have a lot of practice. Question 7. You issue a select statement on the bank account table containing an order by clause. Which of the following uses of order by would produce an error? And I think there was maybe a little hesitation, but I think everyone kind of went with it. The gotcha on this one is it uses this aggregate function, or not necessarily an aggregate function, but it uses a function in there. And order bys don't really like functions at all. So, but to look at the other ones, your order by, right here, you can, it's always order by, and then you can either do a column number, right? So the first parameter is either the column number in the order that they're in the select list, or a column name. So like in this case, it's the order by account number or order by one. This is the column number. This is the column name. The last parameter is which way you want to sort. Default is ascending, but you can specify manually if you want to. One thing that I would pay attention to is know how dates are sorted. Okay. Know how dates are sorted. So you are creating some tables in your database as part of the logical data model. Which of the following constraints have an index associated with them that is generated automatically by Oracle? And that's the unique key. So good job on that one. You guys knew that. And this is kind of just stuff you have to know. You were processing some data changes in your SQL Plus session as part of one transaction. Which of the following choices does not typically indicate the end of a transaction? So this one could be a little tricky. This one is actually pretty easy because these two are both that. Ending your session probably would throw a few people off. But you guys got it. That one's pretty, I'm hoping this one's is easy. I think it's going to be. I'm guessing that these are probably pretty indicative of what's on the final. And I guess just to show you a good way to evaluate this one. The way that I evaluated when I first saw it was, okay, an update statement is something you actually do inside of a transaction, like multiple update statements. In fact, we did that in lab 10, I believe, or lab 11, the one where we create all the merges and stuff like that. That's basically an update statement. So, and we'll talk about this a little bit more, the DDL, DML, TCL type stuff. But update is a DML statement, which is really what you do inside of transactions, right? That you manipulate the data inside transactions and that sort of thing. So, so yeah, you would say like save point, step one, and then you would say update, and then you would say commit or rollback. So, well, the update statement does include the set. So like when they say an update statement, that includes update, set, name equal to bill, kind of stuff, like the actual start to finish. So, and we'll talk about those DML, DDL, TCL statements here in just a minute. Okay, you wish to join data from two tables. I'm not going to read this all over again. We know it. We were trying to get the tables to match where A value in column C is equal to 5, even when there's no corresponding value in table C. So we chose the answer that says where A dot C is equal to 5, because that meets this requirement. And then what we wanted to do is say even when there was no corresponding value in table B. And that's kind of what we did here, but there's this little tricky thing that we actually don't see a whole lot of anymore. And that is this little plus, because basically we're saying, look, we want A dot C is equal to B dot C. Now that would make the match, but even when there was no corresponding value. So that's where this little plus comes in. So this stands for an outer join operation, the little plus sign. So someone asked, what is a Cartesian product? It's the outer join operator comparing the values from table A to B. Oracle will return a Cartesian product of the data you're questioned from A with all data from B. And we'll talk about that in just a minute. The Cartesian product would essentially be A times B, which is a cross join. So cross join Cartesian product. If you do let's see, let's pull up a window here. If we were making a join, so like let's say select everything from A, comma B, just like that. This is a cross join or a Cartesian product in ANSI 89, SQL 89. And what it would do is it returns every row in A times every row in B. So A times B. And that's our Cartesian product. And it is the equivalent of select everything from A cross join B. Like in lab 7, where we wanted, let's say we had yes and a no, and then we had a 1, 3, and a 1, 3, and a 5. Well, in lab 7, what we wanted is we wanted a yes 1, yes 3, yes 5. Then we wanted a no 1, no 3, and no 5. This is a Cartesian product. So this would be the result of this if this were A and this were B. So I'll show you where to find those symbols for the joins here in just a minute, because those ones we didn't have practice with, so we will go over those. Okay, so now that I showed you one example, you can see, because those will help a lot. You know, those will get you pretty comfortable. I think you'll feel pretty good about it. So now what I'm going to do real quick, it's already 5, so we're going to kind of hurry just a little bit, is I'm going to go over every one of these terms. How many questions are on the SQL expression test? That's a great question. Let's go look. I'm going to move this over here just in case it shows something. Okay, so it's not showing it. So it's worth 150 points, 420 minutes. Let me see. It doesn't say how many questions. Okay, so there are 20 questions on there, so they're each worth 7.5 points. Let's see, I might give you one real quick here to look at. No, the time is actually like that. Basically, they give you all the time you want. So here's one more sample question. We're not going to go over this one because this one's actually from the test, but I just wanted to show you another example, one that's a little different than what we got on the practice. You might see some like this on the practice, but here's one where it shows you a model and a whole statement with the works yes or no and fails because of what, right? So there's another example. Okay. So now let's go over each one of these things here, and I'm going to show you where to find them, and we'll get as far as we can. I'll try to cover the most important ones, or the ones that I think are maybe need the more attention. Otherwise, more of this is just to show you kind of what I would do if I were studying. And a lot of this is going to help for the, like I said, the vocabulary and the SQL query exam. And the nice thing is with the query exam, most of us probably are, most of the query exam you guys will do fine on, because you've already got the practice. You know, you've been doing it every week. So anyways, this is what I would do. Come on over here. So like the first one, SQL, that's kind of one you could probably just Google, but there is this nice little thing here. So if we go here, and it kind of goes in order for the most part. So modern databases, you know, all that's in here. And the SQL will probably, like I said, that one's probably more of just like a Google it kind of a thing, but structured query language, if anyone's curious. All right, DDL, what is DDL? So these ones are really important, right? Basically from these ones right here are very, very, very important. And then what's just as important is for each one of these underneath, make sure you know how they fit into these statements, right? So we have DDL, DML, DCL, and TCL. So if we go in here, there's some really nice things here. And like this one right here, it says DDL command. So that's one you might want to click on. So then this will tell you all the different DDL commands. We have a create, alter, drop, rename, truncate, and comment. So essentially what we end up with, a DDL stands for data definition language. And what I like to use is kind of like my reminder for those is, sorry, my daughter's crying. How I remember this is I always think, okay, definition, I'm defining my data, right? And so what I think of is I'm dealing with the data definition, or how I defined my data. Now that doesn't mean I can only define data with it, but I can also change how I define data, basically my structure. So when I think about it, think of a database like a house, for example. Your structure, the table, is the frame, the actual house itself. And then the data inside is like your furniture, all your junk, you know, like I'm looking over here at my overflowing closet with all the junk. That's the data, right? And you define how you store that based on your structure. So the way I always remember DDL, data definition language, is dealing with the structure. So whenever you think about it, I say, okay, is this the data within the table, or is this the structure of the table? So like a create statement, obviously we're creating the table. An alter statement, we're altering the table. Drop statement, we're dropping the table. A rename, we're renaming some column name, right? If it's not actually the data inside, it is a part of the structure. So that's a DDL. The next one is DML. And I was going to show you this. If you ever can't find anything, there's a nice little search box here, and it actually works. Right? So that's a nice thing. You might just have to scroll a little bit. Let's see. And then I say that, and all of a sudden it's not as good. And I swear that used to be a lot better. You can also use the Google search within specific ones. The other thing you can do is just go like this. DML. DML, DML, DML. I thought he had a whole article about it. Let's look here. It would be in week 3 or 4. Let me try to search one more time. me try it like this. We might get less results this way. Okay. There it is. Okay. So data manipulation is just like Ben said in the chat. It's the manipulating of the data itself, right? So DML, I always think, okay, now I'm manipulating the data inside of the table. So insert, update, and delete are your go-to DML statements. Pretty much those are it. So and so the way I always chunk those out is because what does an insert statement do? Well, it inserts data into the table. What does an update statement do? It changes the data in the table, and the delete just deletes data from the table. Delete doesn't alter the table, like the actual structure. You know, I can delete my couch, but it doesn't change my house, right? You know, when someone moves from a house to a house, literally it's just like doing, well, you'd copy it first essentially, but you know, delete and everything's out of your house. It'd be really nice if you could do that. Like, you know, I need to clean up, delete, you know, just watch all the junk in your house go away. So anyways, data manipulation is update, insert, update, and delete. You're dealing with data inside of the table. DDL, DML, DCL. And DCL is data control language. All right, DCL. Oh, and here's that nice, oh, the DDL commands. This is kind of what I was looking for. All right, this is the article. I've probably passed it a few times. Anyway, so we have our data definition language. We have data manipulation language, which we also talked about. And then we have data control language. And data control language is how you control access to your data. Okay, that's how I always remember that. I'm controlling my data, right? You know, when you think of someone who's super controlling, what do? Well, they restrict. Strict being the key word, right? So those are just like little ways I play on the words, and you know, and it goes into how they were created. But the control language controls how the data is accessed, right? So when you think of DCL, data control language, think of controlling. They restrict. They're strict and controlling. So they restrict data with grant and revoke commands. So think of your controlling parents, you know, when you're a teenager and you just wanted to go hang out with your friends, but your parents were too controlling. Well, they had the privilege to grant and revoke rights to you. Data control language. Then the last one, transaction control language, and the key word there is transaction, right? So, and whenever you see transaction, know we're talking about begin transaction, save point, commit, and rollback. Okay, so anytime we're doing those little save game features, think of a video game. Transaction control is how we do transactions with commit, save point, and rollback. So anyways, those sound super confusing, but once you kind of like think about it, they're pretty easy to segment out, thank goodness. And there's not like any overlap really. So anyways, let's move on. Again, those are super important. So as we go through these, make sure you're thinking about, oh, is this DDL, DML, DCL, or TCL? A select statement. Now this one is going to be critical too as well, but there's this nice little article called select statement, all right? And this takes you through step by step through each clause and the order of operations. This is huge. Make sure, and like, you know, and I'm just going off of my cert exams. This is huge. In fact, on my cert exams, it would actually ask, what order does this step execute? And there's certain queries where you know, there would be different outcomes, or it would ask, what step does this fail on? Did I have an LDM? I think LDM is supposed to be DML. I don't see it anywhere, but probably just a typo. But anyways, because like for example, that one sample we looked at, it said, what causes us to fail? Well, what happens when we have two errors in a query, right? So let's say you're going through the test and it says, what causes this to fail? Well, you might see, let's say it has two errors. Like let's say it's missing a from clause, or there's something goofed up in the from clause, but then there's also something goofed up in the where clause. Which one do you put? Because there is a right and a wrong answer, because it's gonna throw an error on the first one. So you need to know the order of the operation of the select statement. So as you're going through this, just know this article is here. We don't have time to cover it in depth. Just know, actually, I'll talk a little bit about it. This is going to talk about the order of operations. Now, I'm not going to go super into detail for every step because it does change. It doesn't necessarily change, but things go in weird places when you add like a group by clause. But the way I always remember is, and it's kind of odd because the way it's written is not anywhere close. So the way I always remember is like if I'm saying select everything from X where Y. Okay. So what I do is I always think, okay, if I were the computer, what's the first thing I would do? Now, logically, us as humans, we want to say, well, I wrote the select list first, so that's the first thing that would happen, and that's wrong. Because even if something's not in the select list, we can use it in the where clause. We can use it in the order by clause and all that other stuff. And the select list, all it really does is display the data, but all the other data is actually there on the background. We just don't display it. We don't select it per se. So if I was, the way I always remember this is if I was the database, the key ingredients to all this, the foundation of the whole query is the tables. Where are we getting the data from? So if I was the computer, the first thing I would evaluate is the from clause. And there's multiple reasons for that. A is it needs to know what's in the tables so it can validate if, is this column name actually, does this column actually exist? Stuff like that. So number one is the from clause because it's the most foundation you can get. Where am I getting my data? The second thing that you'd want to do is filter out the data because we don't want to do a bunch of stuff for rows that we're not going to need, right? So number two is the where clause, right? And the where clause includes every and afterwards. I mean, typically we put where and on the same line, but realistically, if we were like formatting this the way it does, you would tab in on all the and subsequent the where clause, okay? But no one does that. So the from clause first, let's know where we're getting the table from or getting the data from. Number two, let's filter the data so we can save some work, right? Because if we only want stuff where the item rating is equal to PG and the item titles like Star Wars, we can filter out potentially millions and millions, billions of rows, right, that we don't have to work on. So first, we got to know where the data is. Two, we got to filter to make our jobs easier. And then lastly, three, we actually choose what we want to select, right? Now, the only difference is that when you add an order by, we would change a little bit. So from is still the same, where is still the same. The third is we would order it, and then we would select. If we add a group by, it goes from, where, group by, order by. Okay, so you just have to read through this because I'm not going to go too crazy. Just make sure you know those, especially down here where you get into the group by and having. Those are, if you understand group by and having, it's pretty logical otherwise, but that's super important. Okay, so there's that. Update statements. I'm not going to go over these. We should know them. Insert statements, again, we should know them. Delete statements, pretty easy. Truncate. So one little thing here, know the difference between delete and truncate. Okay, I'm not going to tell you because that's one that I think is best self-learned because every database interview I've ever been in, everyone, they ask, what's the difference between delete and truncate? Because it's very important. Create statement, we should already know that. Create table, drop, and alter. So these ones all apply to kind of what's below it. So know how to create tables, know how to create sequences, know how to do transactions, know how to drop tables, drop sequences, alter tables, alter sequences, that kind of stuff. Inside your table, know what obviously what a table is, know what a column is, know what a row is. Primary key, make sure you understand what primary and foreign keys are. Make sure you understand indexes. And actually, I probably should add one more. Make sure you know what constraint is. That's missing from here. So understand constraints. And maybe I have that in here. I'm not sure. Sequences, next val, cur val. Make sure you understand those. Those are important. The transactions we've talked a whole bunch about, but make sure you know what those are. Our joins. So I'm going to show you this again. This will save your life, especially in a test, because even up until through my master's degree, when I took tests, one of the first things I did was I would actually, and I have them committed to memory, but whenever I got to a problem, I drew a Venn diagram because it helps me really visualize. So, if you don't have these committed to memory yet, commit them enough so that, or just, pull it up because you can actually look at it. I forget that this isn't like a certification test for you guys, but these will help a lot. So if you're ever looking at a join, pull up this because it really helps you visualize. Like on that one sample question, we wanted everything from A, where C was equal to a certain number, even if it didn't have a match in B. So that would be our stuff. It really helps you visualize. So let's move on. We're running out of time. We're down to 8 minutes. And so I talk here, know the ANSI 92 and ANSI 89 versions and the differences. Okay. No, and these are, again, some that we didn't cover too much on, and we actually might have. I can't remember. It was a long time ago. Know what a union is. You know what an intersect is and know what a minus is. Okay. So union is creating a list. So let's say we have two to-do lists, right? Let's say I made a to-do list, my wife made a to-do list, and we're going to town and we want to get all of our stuff done. Well, a join would glue things horizontally. So like if I was going to join these two windows here, I know this is kind of a lame example. If I was going to join these two windows, I would do this because they go horizontal, and then I would read across rows like this. A union is basically combining a list or adding to a list. We're going to do it like this. So if you picture your columns, instead of joining them on the side and adding like rows, like columns to a single row, you're actually just adding more rows. So that's a union. And all three of these deal with a similar thing. So our union adds rows. Intersect finds the same thing. So like, let's say I have not necessarily, kind of. Really what it's used for is like, let's say you have two tables, right? Let's say you have, where's my, oh, that's not what I wanted. Let's say you have two tables. Let's say you have a student table and a staff table. And let's say you want to get an email list for everybody in the organization. Let's say that it's first, last, and email. Now there could potentially be other things here like student number, right? And let's say that it's similar. So let's say we have first, last, email, staff number. Now this is a good example because if we were, going to do a join, there wouldn't be any common data between here. But what we want is a list of everybody to do. So what we would do is we would say select first, last, and email from student, right? And we would get that. And then we would do another one. We'd say select first, last, email from staff. Now, you know, you might think, oh, we'll just run both of those, pump them into 2 CSVs, and then copy and paste. Well, no, that's caveman, right? We're way better than that. We're database people now. So we're not going to mess with a CSV when we can do it right in the database. So what we do is we just take off this little semicolon here, and we say union. And bam, we end up with one whole list in one query, right? Does that make sense to everybody? Okay, so another example, okay, real quick. So we're going to kind of use this same thing here, but we're just going to change up these tables a little bit. So let's say that, okay, here's a good example. I do a lot of database work with schools, high schools, and they do a lot of concurrent courses, meaning that they take a class at the high school and they take a class at college. Well, actually, that's not a good example. Let's think. I'm having a hard time thinking of an example. Okay, so let's say we have our student table, right? Oh, here's a great one. We'll leave it just how it was. Okay, so we have student and staff, right? Now, how many students are, and let's change this from staff to employee. That'll be a better example. So we know that there's students, we know there's employees, and we know that there's some employees that are students, right? So there's kind of a little bit of a mix here. Now we could do a join, right? But let's say that we want to find all the students that are employees really easy. Now we could do the whole join thing, but what we can do is we can do an intersect. So we can say intersect. And what this will give us, it will give us everybody in here who has a record in here matching. So obviously if you have a separate email, then it wouldn't work, but it is there. We can look that up right here. So intersect. You can join rows between two queries by several techniques, blah, blah, blah. This is our intersect. Like I said, we could do this with a join, or you can do it with this little intersect. Now, intersect comes really in handy for a lot of reasons. Stuff like that is really nice. Let's look at the last one. Oh, and then minus. So let's do one last example here. So let's say that we want all the students who are not employees, right? So let's say we're sending out a message to students to let them know that there's jobs available. Now, we don't want to bother students that already are working for us, already have jobs. So we can minus. So then we end up with all the students minus those that are already a staff member. So really quick stuff like that are super, super, super handy. And we can look up the one for that as well. And you know, this kind of walks through it. So if you have any questions, you can look at that. Okay, and we're about done, which is perfect because we've got 1 minute left. So subqueries, know these really well. So a single row subquery, multiple row subquery, scalar subquery, and correlated subquery. And there should be one in here that talks about subqueries. somewhere. Here's a correlated query. But there's your scalar subquery. It'll talk about that one. I have not looked at Slack. I came right from work, so I will take a look. 2 number 5 questions with different answers. I'll take a look at it. It most likely is just an issue with the practice test. When did the test actually open? Real quick though, before I get too off task, know those. You can search them, and then also know how to do a grant with basic permissions, like how to grant read, all that kind of stuff. And we've kind of done a little bit of that in the lab. Well, actually, I think they took that part out to do it for you. But do a little bit of that just so you know. The tests open. Let's look. I think they're open. Let's see. I know okay, yep, okay, so they are open. Cardinality of columns. That's another one I should probably add to that list, actually. So the cardinality of columns is, and that's all in chapter 3. So what I'll just show you where it all is that you should know for those. So they're in week 3. I thought it was in there. Let's. I know where it is in the book. Worst case scenario. Cardinality. Okay, so I think. Yep. Okay, so here it is. And what article is this in? So there's one called Dependencies. And it says how to read relations. And this is a good example. So a kingdom may rule over many knights. So one to many. And then it talks about how to map those. Or was it in here? Could have swore somewhere. Well, let's do this because I don't know if there's like a good one there. I think there's a really nice yeah, so there's a few good ones here. This is basically it. So now that's continued. Where's a good exhaustive list here? Okay, this is a good one. I'm actually going to send this to you guys. So this goes through each one of them with an example, which is really nice because that's the easiest way to remember. So like, for example, a one-to-one relationship. The student is allocated to only one hostel room. And when they talk about a hostel, think about it like a dorm room. Do you need help with writing an assignment? No, we don't. Do you need help cheating on your homework? I'm an academic consultant. Anyways, so yeah, this is a good resource for this, not so much for this. So anyways, one-to-many. If one student has to complete exams for more than one subject, the relationship is one-to-many. Anyway, so yeah, so those are good ones, and I should add those to my thing. In fact, I will. Cardinality. All right. Does anyone have any other questions? And I guess the biggest thing is don't fret too much. I mean, there's plenty of time, right? There's plenty of time. So just go slow. Really, it's just about being super methodical. Making sure you read. Reading is huge. Just as you're going through, obviously I say reading is huge, but it really is, because a lot of these might be a little tricky, and you don't want to miss one over one little thing, especially where you have so much time. So make sure you give yourself a lot of time, double check yourself, do all that kind of stuff. I don't remember what the question was. Let's see. The last question, was that the one with the join, right? Basically. I can't remember what D was. Let me see if I can find it. Let's see. Oh, okay. So if it was just an AC is equal to 5, because remember, we kind of had two conditions we wanted to meet. One is that A dot C was equal to 5, so we meet that condition. But we wanted it because if you remember right, C was essentially the key column between the two tables, and that's kind of the kicker. So we wanted it even if it didn't have a match in B. And so we did the outer join. Well, we had to add that one clause to basically show where the matches were, right? Because otherwise we end up with the Cartesian product. And it kind of talked about that. So if I pull this up again, because remember, if we're talking about A and B here, but let's change, well, without changing it too much. Let's leave it like this, right? So let's pretend, well, yeah, let's change this. Right, so let's say I have two tables and they are just 1, 3, and 5 essentially. Well, we end up with the Cartesian product regardless. Anytime we do a join like this, we end up with Cartesian product, which is 1, 1, 1, 2, 1, 3, and 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, and 3, 3. So we end up with this. So this is actually how I would think about it, right? So you already know you're going to have a Cartesian product because they're using the old join syntax. Because remember, in week 5, we talked about the efficiency of the difference between ANSI 89 and ANSI 92. And in this case, because what we're doing is we're essentially getting a Cartesian product, which is every possible combination, and then we filter down to the ones that are accurate or the ones that we want. So given that we have the Cartesian product, now we want to filter. So we would say where And instead of C is equal to 5, I'm going to say C is equal to 3, okay? Oh, and I actually did 1, 2, 3 instead of 1, 3, 5. So let's change this to 1, 2, and a 3, and a 1, 2, and a 3. So I'm gonna pretend that 2 is the one we're looking for. So we want to say where A dot, well, A dot 2 is equal to 2, right? A dot, let's call it A dot A for column A, because we only really have 1, is equal to 2. Well, we would get all these where A is equal to 2, and this is A and this is B, right? So we would filter that out, and we would be left with these guys, right? But we still have a B as a 1 and a B as a 3, because we want that match there. And so what we added was, and A dot A is equal to B dot A. You know, just the single column, we could just say A and B. But then, so because now we, in ANSI 92, we actually have outer join type stuff where it's an actual keyword. However, in 89, all we have are where and to make our determination for how we're doing this join. So back then they had this symbol, the little plus symbol, and that is just the sign of an outer join. Okay, and it's really the only one, because an inner join is where you would say, like if we were doing an inner join, we would say where A dot A is equal to B dot A, right? And we'd leave it at that. However, where we're doing our outer join, we specify that same join condition because that's our foreign and primary key combo, but then we specify the outer join symbol right here. So a left outer join, or apply the outer join operator to all columns of B in the join condition in the where clause. And yeah, I'm actually surprised that's on there. I'm actually going to flip through the test questions because that could just be a one-off, and at that point, it's just know to recognize it really. Other than that, I think you'll see more of the other than this. I think this is a one-off kind of a thing. The logical data model, that can mean a lot of different things. Let's take a look. I think they're kind of just like, I think it's just a fancy term. Yeah. Basically, it's a fancy term for storing stuff in a way that's logical. So a logical data model, a logical scheme, is a data model of a specific problem domain expressed independently of particular blah, 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 but in terms of structures, such as relational data columns, object-oriented classes, or XML tags. So think of it logical. So like we store data with things that make sense to us, like a class. We make a class table. A school, we make a school table, that kind of stuff. So I wouldn't get too hung up on the logical data model. Just know that pretty much most things we talk about are logical, because I think it just said given a logical data model, or did it actually? Do you remember where you saw LDM specifically? Yeah, so I wouldn't get too hung up on it. Basically, it's like saying like, oh, given that we're organizing our table in a normal way, that's kind of what it's saying. So I wouldn't get too hung up on it. But good question. All right. Any other questions? No, I would not say a Quizlet is cheating. If you want to take your notes, and because to me a Quizlet is basically a way of creating notes, right? Um, Creating notes in a piece of technology that makes it easier to study. Feel free to use the Quizlet. Um, and you can even say feel free to share the Quizlet. Now, the one thing I would say about sharing the Quizlet, I don't have any problems sharing the Quizlet, but what I would say is keep in mind that part of learning is actually creating the Quizlet, in my mind, right? You can use an existing Quizlet if you want. That is a-okay. Like I said, just keep in mind that like if it were me, um, and there's always that happy medium, right? Because I'm not saying like, oh, you got to do it all from scratch, um, but to me, part of it is like, and I know everyone learns different, but for me, part of the learning is actually um, creating it. Like the fact that, oh, I go look it up and I actually type it in the Quizlet or copy it in the Quizlet, whatever. That action for me helps me like store it in my brain memory. So um, just keep that in mind, as you're studying. That's my only piece of advice. But yeah, feel free. That is free. That is great. All right. Well, if there are no other questions, I will leave you to it. Um, Lab 12. Lab 12 is extra credit. Feel free to do it if you want. Feel free not to. Stuck on step 3. Okay, let me. I'll stop the recording and then we can go over that real quick. And yeah, the screenshot might be wrong, so we'll take a look. But anyways, for the rest of you, good luck studying. Don't feel free to take the exams as early as you want, but don't take them too early if you don't need to. Just do it when you need. So, anyways, let me